Hello, my name is Inma Roch. I am head of Composites department in AIMPLAS, Tecnológico Instituto of Plastic, and I would like to present a webinar related with composites materials and different case studies regarding to these materials. My presentation follows next index. First of all, I would like to show an introduction about composites materials. After that, I'm going to talk about these raw materials, and so finally I'm going to explain different case studies in which ones AIMPLAS participates as partner. Composites materials are constituted with a combination of two different materials in order to obtain unique properties to the final material. In this case, we can define two different materials, reinforcements and matrix. Reinforcements contribute to the mechanical properties of the final part mainly. And matrix forms geometrically the part, and they don't provide mechanical properties, but they transmit stress between the fibers of the reinforcement that we use. Why we use fibers and matrix? With these materials we can adapt our requirements, because we have a wide range of materials, so we can select it in function of our final properties. And also, it is important to remark that reinforcement can be placed in the direction that we need in order to obtain the final properties of the part. In this case, metals and other materials are very limited in comparison with fiber-reinforcing composites. Nowadays, composites are materials in expansion, which are replacing other common structural materials. The main reasons are related with the relation between mechanical properties and weight. And we have to take into account the influence in cost of the maintenance of these products. Regarding to this point, mechanical properties, here in this slide you can see mechanical properties of common structural materials. In this graph, we can compare the information related with common structural materials like wood, alloys, titanium, and steel, in comparison with different kinds of composites materials made by different kinds of reinforcements: glass, aramid, carbon, and so on. So, as you can see here, we have, except the steels, we have very good mechanical properties of the composites materials in comparison with the structural materials. So, and also, I would like to remark that we have a wide range of mechanical properties. So we can adapt, as I mentioned before, our final properties to our requirements, and we can select the suitable material to our final properties. In this slide, you can see the density of the different common structural materials that I mentioned before. Here, as you can see, steel has a high density, so in comparison, we can obtain very good densities for the composites materials. So, as I mentioned before, composites materials has an important impact in different sectors because of the relation between mechanical properties and weight. So in this slide you can see this aspect, this item. So because if we compare mechanical properties between the density of the different materials, we see that composite materials has an important advantages in comparison with the other materials that we can find in the market. And also we can identify the wide range of mechanical properties that we can obtain with the different combination of composites materials. As I mentioned before, composites materials has an important impact in different sectors, and this is related to their different advantages as weight reduction, specific mechanical resistance. Also, they have an important impact related to corrosion resistance. So this is the reason that they are applied in different sectors like marine application, wet applications, and so on. They can provide electrical isolation, and they are stable in dimensional. And also, these materials can provide a high temperature resistance. Now we are going to move to the point related to the raw materials which we can obtain a final composites part. In this point, as I mentioned before, we have the matrix and the fibers. Matrix form the part and provide the flexibility to the part, and fibers provide the mechanical properties. But we have also other materials, like fillers and additives, which can provide other different properties, like fire resistance and so on. In the case of matrix, we have different kinds of matrix: organic, minerals, metallics, and ceramics. We are going to focus on the organic matrix. And in the case of fibers, we have, as I mentioned before, different kinds of glass fibers, like glass fibers, carbon fibers, ceramide, and boro. First of all, I'm going to talk about the reinforcement that I mentioned before. They provide mechanical resistance, stiffness, and hardness to the final part. And we can classify these materials in relation to the origin. We have mineral origin and organic origin. In the case of mineral origin, we have inorganic fibers like glass, carbon, boro, ceramic fibers, and metallic fibers. Ceramic and metallic fibers are used normally in the combination with ceramic and matrix fiber, ceramic and metal matrix. And in the case of organic origin, we have aramid fibers and polyethylene fibers. In this slide, you can see the most important reinforcement and the estimation market by volume of these different reinforcement. Glass, carbon, and aramid are the reinforcement more used nowadays. The reinforcement more used are the glass fibers because we can obtain good mechanical properties in relation to the price of these glass fibers, and glass and aramid fibers are used in specific sectors. Carbon fibers are mainly used in aeronautic sectors, and aramid fibers are used in the sectors which the impact resistance is it's the most important property. We can also have different kind of fibers, but nowadays we can see that natural fibers has obtaining a good influence in the market. Nowadays they are introduced in the market due to environmental issues, and we have nowadays in the market sisal, hemp, flax, and kenaf fibers in order to cover this opportunity by the use of natural fibers. Now we are going to move to the different presentations that we can find, in which we can find the reinforcement. So for first of all, we have the chopped robin. It's a yarn of different fibers, which can be used normally in the sprayer process in order to obtain, cut different fibers, and to obtain combined with a matrix. Normally, these chopped robins are formed by glass and combined with different polyester resin normally. We have also the other presentations like chopped strand mat. In this case, we have a ply of different short fibers, normally by glass fibers, which can be used in high layup applications and also combined with different parts made by hand layup in order to obtain better mechanical properties and better quality of the final part. Also, we have continuous filament mat. It's similar to the chopped strand mat, but in this case we have the fibers, the short fibers, are longer than in the case of chopped strand mat. So we finally can obtain better mechanical properties, and this kind of material can have more flexibility, so they can adapt to the form of the mold easily. After that, we have also direct romids. In this case, we use this kind of materials for pultrusion process, for example, in which one we obtain composites profiles with a determined form with high mechanical requirements. And also we have different combinations of fabrics and complex. In the case of fabrics, here you can see in this slide you can see the form of the fabrics. We have different robins woven in different forms and different textiles. And also, finally, we have the bales. In this case, bales the bales don't provide mechanical properties. They provide a good quality surface to the part, in order that we have a final good surface for our part. Now we are going to move to the matrix, the other important part of the composites materials. In this case, the matrix are organic compounds with high molecular weight, which are product of a reaction of polymerization by addition or condensation of different compounds. We have three types of matrix: thermoplastic, thermosets, and elastomers. But in this presentation, we are going to focus in thermosets matrix, which are used normally with combination of the different reinforcement that I mentioned before. But first of all, I would like to mention that thermoplastics and thermosets has an important difference. In the case of thermoplastics, macromolecules are joined between themselves by low intensity strengths, so they melt by heat. And different examples of thermoplastics are polypropylene, polyamides, and polycarbonates. But in the case of thermosets matrix, the strengths of the joint of the macromolecules are very intensive. So these macromolecules could be broken before melt if the temperature will be increased. And different examples are phenolic resins, epoxy, and polyester. In the case of resin matrix, I would like to remark four types of resins. First of all, it's phenolic resins, which can be used mainly due to their good fire resistance. An example of phenolic resins is bakelite resins. Also, we have vinyl ester resin, which are in the middle way of epoxy resins and unsaturated polyester resin, because they can be used as unsaturated polyester resin, but they have more similar properties to the epoxy resins. After that, we have the epoxy resins, which are used mainly in sectors with high requirements, for example, aeronautic sectors. But we have to take into account that epoxy resins has a restricted conditions in order to cure. But they provide also very good stability in comparisons to other type of resins. So this is the reason that they are used in sectors with strict requirements. Also, we have the polyurethane materials. In this case, the polyurethane is one of the most versatile materials that we can find. So we can obtain different type of polyurethanes, thermoplastic, thermosets, and elastomers. But in this case, I would like to focus that polyurethane is obtained by the mix of polyol and polyisocyanate in order to obtain the final polyurethane with different characteristics. And finally, the last matrix is the unsaturated polyester, which is the most used as I mentioned before. In the case of reformant, the most used is the glass fibers, and in the case of resins, it's the unsaturated polyester. Normally, they are combined, glass fibers and unsaturated polyester resin. This resin is used normally with a catalyzer and an initiator and accelerator in order to obtain the final cross-linking of the polyester resin. As you can see in this image, here is this image of different unsaturated polyester resin with a combination of different catalyzers. As I mentioned before, I would like to introduce different case studies in which AIMPLAS has participated related to composites materials. In this case, in the first case study, we can see different applications in shielding materials. In this case, the results of these projects can be adapted to shipbuilding, vehicles, aircraft, helicopters, and textile protection. The main topic in ballistic protection is the selection of the type of materials. In order to obtain a light material and adapted to the different requirements established in the standards. So in this project we develop a material adapted to shipbuilding in order to protect the, in this case, the shipbuilding in front of ballistic attacks. So finally we obtain a reduction of 20% of the weight in comparison with traditional materials used for these applications. Materials used in this project are mainly focused in aramid fibers. Aramid fibers, which commercial names can be Kevlar and Tauron, are important due to their impact protection. Final applications has some advantages related to the good mechanical property regarding to impact, and also the lightweight and the possibility to use in a corrosion environment. Next case study is related to Valencian Sport Lighthouse. This new lighthouse is located in north extension of Valencian Sport. This infrastructure is made of composites materials, and it has a height of 32 meters. In this project, Acciona Infraestructuras was in charge of the construction of the lighthouse, and Autoridad Portuaria de Valencia was the agent of the project, and AIMPLAS participated as technical assistant to Valencia Sport. As you can see in the image, the new lighthouse of Valencia Sport, it's made completely of its infrastructure made completely of composites materials. It's a self-sufficient infrastructure with solar panels and different systems in order to provide energy of the lighthouse. And the main advantages of this structure and the use of composites materials in it, it's the reduction of building time, the reduction of contamination associated to building in traditional methodologies, and the better behavior of these materials in marine environments. And also, as I mentioned before, the reduction in maintenance tasks. These materials has a good behavior in corrosion environments, so the maintenance is better in comparison with other traditional materials. Also, we have to take into account that we can reduce the environmental impacts of the different building materials if we use these composites materials. And the most important advantage is the reduction in weight. Because as we can see in next images, here is the moment in the lighthouse was located in the Valencia Sport. This lighthouse was fabricated in Madrid, in Acciona facilities, and was transported by road to Valencia Sport. And this is the moment in which the lighthouse was located in the final place. So in the other images you can see the different steps of the stairs, the inside stair of the lighthouse, which was made also by composite materials. In this case, the process to obtain these different steps are RTM, resin transfer molding, and these materials these stairs were made by glass fibers and different resins, as I mentioned before. In next slide, you can see also the final position of the lighthouse in Valencian Sport. And here you can see the different components of the lighthouse, in which you can see the profiles obtained by pultrusion process, stairs obtained by RTM process, resin transfer molding, and different structure made by pultrusion or infusion process, common processes in the production of composites materials. So with the obtained results in the new lighthouse of Valencian Sport, we can demonstrate the applicability of the composites materials in different kinds of infrastructures, like pedestrian bridges, stairs, platforms, towers, for example. Now we are going to move to other case study, biocomposites. As I mentioned at the beginning, natural fibers has an important impact nowadays in the composite sectors. And in this slide you can see different applications of biocomposites, natural fibers and bioresins provided by renewable resources. In this case you can see an electric car charging station made by jute plain fabric and an epoxidized acrylate soybean oil resin, processed by BART process, vacuum assisted RTM process, vacuum assisted resin transfer molding. In next slide you can see also different case studies produced by biocomposites in different European projects in which AIMPLAS participated. Here you can see a grid container made by bio-based unsaturated polyester resin and also furan resins combined with flax and hemp fabrics. And this container is made by wet compression molding. And also here you can see a motor cover made by bio-based unsaturated polyester resin and flax and hemp BRCL fabric and produced by light RTM, light resin transfer molding. And finally, as a summary, we can conclude that plastics and composites are a real alternative to be used in different sectors due to their important advantages such as weight reduction, easy assembly, maintenance and flexibility regarding to the design, among others. We explain different case studies in which these materials are used, like shielding, in which demonstrate that it's possible to use composites in shielding sector due to the lightweight and these materials are adapted to their standards of these sectors. For example, STANAG 4569 at level 1. And also in the case study in which we explain the lighthouse of Valencian Sport, we can demonstrate also the applicability of these materials in this kind of structures. And also, I would like to remark that biocomposites are a clear alternative due to an additional reduction in weight due to the density of the low density of the materials, and also taking into account environmental issues. So, finally, I would like to remark that plastics and composites can be used in different sectors due to the different advantages that we mentioned before. So, thanks for your attention.